Good afternoon, and welcome to Failure is Not an Option, a 5-phase process to dramatically increase uptime and reduce breakdowns, hosted by Chevron. I would like to get us started by covering a few things that will help you get the most out of this webinar. To get a full view of the presentation, click the orange arrow on the Grab tab on the left of your control panel to minimize the panel. This will place the tab on the top right of your screen and will enable you to see the entire presentation. We'd like to encourage questions. To ask a question, bring your control panel back by clicking on the orange arrow and type your question in the box that says, "Enter a question for the staff." We will answer these questions at the end of the session. Thank you for attending today, and make sure you ask questions as they arise. At this time, I would like to introduce Dan Holdmeyer, the Industrial Sector Manager for Chevron, to kick us off. Dan, welcome to the webinar.
Thank you, Haley. Hello and welcome. Thank you for joining today's webinar. I've worked at Chevron now for over 15 years, actually over almost 19 years, all in various parts of lubricants. I'm an engineer by training, and in my years at Chevron, I've spent many years working in the construction sector with OEMs, equipment managers, and maintenance managers. One thing I've learned is that for an operation to run smoothly, strong preventive maintenance practices are key. Preventing a breakdown is invaluable to your operation. Yet not all maintenance practices are created equally. So it's good to stay current on what the experts recommend. So we approached the publishers of Equipment World to create a webinar on practices for preventive maintenance. I hope you find this information informative and helpful to your business. I would now like to introduce our presenter, Preston Ingalls, President and CEO of TBR Strategies. With over 45 years of experience, Preston Ingalls, President and CEO of TBR Strategies, has led maintenance and reliability improvement efforts across 30 countries for Toyota, Royal Dutch Shell, Exxon, Occidental Petroleum, Hess, Mobil Chemical, Era Energy, Skanska, Bayer, Baxter Healthcare, Lockheed Martin, Unilever, Monsanto, Pillsbury, Corning, and Texas Instruments. He consults extensively with construction industry fleets and the oil and gas industry in the areas of equipment uptime and cost reduction. He holds 2 undergraduate degrees in engineering and a master's degree in organizational development. He is a contributing writer to 6 trade publications and has written over 60 articles. As a reminder, you can submit questions in the control panel, and I will direct you to those to our presenters and sponsor at the end of the formal presentation. At this time, I will turn the presentation over to Preston.
All right, thanks, Dan. Thanks, Haley. I'd like to welcome everyone to Failure is Not an Option, and I want to give you some techniques and pointers on how to reduce breakdowns and improve uptime on your equipment. I've been doing this for, as Dan shared with you, about 4.5 decades in both maintenance and engineering, and I've been to about 30 countries across the world helping companies improve their maintenance practices. So one of the things I like to do is kind of start off with what constitutes breakdowns. We know that neglected deterioration obviously contributes to it. We also know that improperly operating the equipment, when people abuse the equipment and neglect it or operate it beyond its design parameters. We also know that design flaws are an issue as well, the inherent weaknesses from design issues in equipment. We also know that lack of routine maintenance and inspection. And this could be preventive maintenance, it could be corrective maintenance, it could be predictive maintenance, but just a lack of consistent or routine maintenance can contribute as well. Also, we know that insufficient skills and knowledge, both of the person operating the equipment and the people that are servicing it, can contribute to these. So what I want to do is kind of take it from a 3-phased strategy to show you some of the principles behind it. One of them is mitigation. You have to have a strategy to mitigate, keep small problems from becoming major problems. If we can prevent things from occurring, we don't have to worry about catching them. But unfortunately, some things slip through. And so our second phase is the detection phase. And this is applying preventive, predictive technologies frontline maintenance, other types of things to inspect, detect, and correct problems before they become expensive ones. The third is restoration. It doesn't do any good to detect these things if you don't have some strategy to correct them before they run to failure. So those are our three major principles that drives a lot of the activities that I'm going to be sharing with you. First, I'd like to share with you is an actual case study from one of our clients I've been working with for about 18 years. A company called Barrier Construction out of New Orleans. And what you see is a table on the right that shows their progress over time. As we saw when we first started this process back in 2000, they were doing about 15% preventive maintenance, and that's 15% of the total maintenance hours were dedicated to preventive maintenance, while 60% was dedicated to emergencies. Generally, we define emergency as something that has to be done within the next 24 hours. It is an emergency. So at that time, they were spending almost 2/3 of their activities on emergencies. Over a period of time, you can see as that chart, as that table shows, we were able to make significant progress by increasing the preventive maintenance, increasing corrective maintenance, and therefore we were able to reduce emergencies. We see a little blip down towards the bottom in 2006, and that was because of Katrina. Obviously, it was a major shock to the system. It impacted their equipment, the culture of people, etc. And you see we had a little slippage there, but we bought it up and showed that, hey, we got to get back on target. It's kind of like a diet. You get it off of it, get on the scale, and you see, hey, I picked up a few pounds. We get back on the diet. So we kept working at it and increasing the level of preventive and predictive maintenance. And you can see 2017, when I did their audit, they were 55% preventive maintenance, and emergencies was 1%. So what I want to show you is how it was accomplished. Or another one I'd like to be able to do is share another case study. This one is the Gorman Group, and they're headquartered in Albany, New York. They have about 225 employees. In fact, I was just up there this week conducting their annual audit. They cover mostly the Northeast in paving, but they also produce emulsions. They have a emulsion manufacturing facility and a very large deep water asphalt terminal on the East Coast, and also have a rail terminal as well. We've been working with them for some time, but they cover 550 municipalities and doing surface repair, asphalt surface repair, and they may send crews as far south as North Carolina to serve as subs. So what happened was they realized, they started looking at their costs and realized they had an issue. This is back in the mid-90s. They were in the red each year when they looked at equipment revenues versus equipment costs. They were spending more than they were bringing in. So in 2008, we were invited to come in there to look at their maintenance practices and their fleet. Now, I think a picture's worth 1,000 words. So this is some of their shop conditions. You can see a lot of contamination there. We'll be talking about the importance of lubrication. One of the most important things about lubrication, which you go all the way to the very beginning, is contamination control. And you can see here, obviously a very poor job of controlling contamination. Here's what the shops look like. That was pretty typical of their workshop. So what we did is we began implementing these processes and training operators, and we started putting in operator care standards, holding the operators accountable to maintain equipment at certain conditions. What you see on the left-hand side is a standard for the pickup trucks. And what we also had to do was put in a process to ensure compliance to those standards. What you see on the bottom is the audit. So they use an audit to assess the compliance of those standards. So we send auditors out, and basically these are people that are trained in-house. It takes about 3 hours to do the training, and we show them what to look for and how to deal with the operations people, and foremen, et cetera, in auditing their equipment. So this is an important part because this represents frontline maintenance, and I'm going to talk more about that here in a little bit. Another thing that we did was, because they cover so many different states, they obviously couldn't dispatch a mechanic from a central facility in their Amsterdam, New York shop to all these different states. So they might be paving in Maine, in the same week be paving in Vermont and New York. So one of the things we did is we helped set up a proxy tech program where we trained operations to perform certain maintenance tasks. They actually call it second in command. And this person is responsible for maintenance service and upkeep on that equipment. So we did a lot of those things, revamped their preventive maintenance practices, got them to use a computerized maintenance management system, and looking at those things. And what we wanted to do was get their costs down and get their uptime up by reducing their emergency rate. So what were the results? Well, it's the old saying, show me the money. And here's a result of their costs from 2008 to 2016. They were spending 14.6% of their maintenance costs is 14.6% of their estimated replacement value, also known as fleet replacement value. So it's the cost to replace your assets or your equipment fleet at today's prices with comparable equipment. Not all brand new, but if I had to go out and replace in kind, what would that cost? And so you can see in 2008, they were spending almost 15%. By 2016, we got it down to 4%, and where they are today, because as I said, I just conducted their audit this week. Now, how do we do that? Well, one of the things we had to do is get them away from the emergencies. And one of the things is, here's a perfectly good illustration of how it was. So in 2008, they were spending about a third of their maintenance activity on emergencies. That's 1/3 of their total maintenance hours. By 2016, we got it down to 1%. And that's where they are today, between 1% and 2%. They like to keep it less than 2%. That means 98% of their activity is basically planned and scheduled. They have 2 planners, and those people, they have a planner and a scheduler, and those people plan the corrective maintenance and preventive maintenance activities to prevent these emergencies from occurring. Now, the model that drives this thing is called the PF, or P2F curve. And this has been around for a long time. Actually got started many years ago in the aviation industry, moved to NASA. Actually, the forerunner was in the military, and then moved to the aviation into NASA. NASA and for the shuttle program, et cetera. And it makes a lot of sense. What it says is that components degrade. And when they get to a point of failure, then obviously it causes equipment to lose functionality. Now, the P point is the point where the potential of the failure begins to occur. So that's where the degradation now starts to get to a point that we can actually, it will lead to failure. That's called a P point. That's potential. It runs obviously to the F point, which is failure. And this failure could be the loss of functionality of the equipment, loss of quality. It's no longer able to do what it was designed to do consistently. That's the F point. Now, the good thing about this is that usually there's a window of opportunity between P and F. And this gives us an opportunity to take corrective action. And that's what we're banking on. That's what your dentist will tell you. That's what your doctor will tell you. If you can diagnose these things at early stages, you can actually prevent them from going to failure. So I can take care of it while it's a small cavity versus later, if it runs to failure, it's going to be a root canal or extraction or something far more painful and far more costly. And speaking of cost, let's look at it. So as you get closer to the point of failure, your cost begins to escalate. And of course, when you get to the F point, when it fails, generally the cost is going to be about 4 to 5 times the cost to correct in the earlier stage. Again, using the example of the dental work, my cavity is going to be about 4 to 5 times cheaper than that cost of that root canal. So this is what we're trying to do, is trying to find this thing in an early enough stage to prevent these things from running to failure, and therefore we can save a lot of money. Now, what we're trying to do is move from an unplanned state to a planned state. So the unplanned state is when you're doing emergencies. That's corrective maintenance, but it's unfortunately emergency, what we call EM. Now, what we want to do is we want to move from this unplanned state to a planned state. Generally, there's two major sources of work there. There's preventive maintenance and there's corrective maintenance. We call that PM and CM. Now, PM is, there's two major types. That's what we call interval-based or usage-based types of service, where we go in at certain intervals, could be hours, tonnage, mileage, fuel burn, or whatever. But we go in there and we perform certain scheduled services. Now, the other one is what we call condition-based or condition monitoring, also known as predictive maintenance. What this is that we use various technologies to get us an early lead indication. And so we may use oil analysis, which we'll mention later on, or infrared thermography, or vibration analysis, or shock pulsing, or many different things, many different technologies to give us a more accurate and earlier ability to detect the changes in conditions. So what we're trying to do is to try to move people from an unplanned state to a planned state. It's going to be less expensive, it's a lot easier to predict, it's a lot easier to manage. When you're in an unplanned state, it's very, very difficult to manage anything. You're just responding from one emergency to another. Now, I'm going to look at this PF curve in a little bit different manner, a little bit more information. So you look to the far right, you'll see the priority one. That's stuff's got to happen immediately. That's usually our emergency maintenance. It's run to failure. And generally what happens is sometimes that also causes collateral damage. That's associated damage, whereas one part might want to damage another part, etc. There's two types of collateral damage. There's immediate, and then there's long-term. Immediate is what you see immediately, but sometimes we set up metallurgical fatigue, stressing, other types of things, and it might be some time before we see the result of that collateral damage. The next thing we have is we want to be able to detect this before it's too late. So what we do is we have a process called operator care. Now, operator care is asking the operators to use their senses of touch, smell, sight to look for the symptoms of these changes in condition. Now, we call that operator care, or OC. And so it's kind of gets closer to the point of failure. Usually it'll show some kind of external symptoms. And we want the operators to be able to detect those symptoms so that we can actually take care of it before it actually runs to failure. Now, another phase is a little bit further back. We do this interval-based or usage-based activity. We call that preventive maintenance. So at certain intervals, we go in there and we do service. Now, the most important thing is not just the lubrication services that occur during that, such as, oil lubrication, changing filters, those types of things, but it's actually the physical inspection. Looking at components and looking at wear points and those things and making judgment calls about, hey, it looks like this thing's going to fail, this belt looks in bad condition, based on the fact that it's spraying, cracking, I see black powder underneath, or, this hose looks in bad condition, it's probably going to be a very short period of time before this thing fails. So we call that preventive maintenance. We're in there at certain intervals, time intervals, so it can be mileage or tonnage or whatever, and we do these routine tasks. Now, a little bit further back, we can actually conduct something that's called predictive maintenance or condition-based monitoring. What this is using some of the technologies of thermography, wear particle analysis, oil analysis, vibration analysis, etc., because they could give us longer lead times of detection. So what we're actually doing is we're using some of these technologies to monitor changes in conditions by comparing points of where we're at against known engineered limits. So we know what it's supposed to be. We know what it was tracking. But now it looks like it's starting to get out of control. And so therefore we can go ahead and schedule this part to be replaced or make some kind of adjustment or whatever long before it is ever able to be detected visually through a PM program or through some form of auditory signals or heat or whatever that you would find from an operator. So it gives us much earlier detection. So it's like running the blood test as part of your annual physical. And it's going to give the doctor a lot more indication than just taking the your blood pressure and checking your height and weight and stuff. It's going to give a lot more accurate information and longer lead times for changes in condition. To the far left up here, we have something that we call proactive maintenance. Now, proactive maintenance are those tasks that we do to basically strengthen the uptime on equipment by preventing these things from occurring. Well, the first one up there on the top is lubrication excellence. And we refer to that as tribology. The science is called tribology. But lubrication excellence is using the right amount of lubricant, the right type of lubricant, making sure people have the right skill sets and applying them, etc. We'll talk more about that here in a little bit. Also, precision maintenance is be able to make sure that we have that we are keeping everything properly tightened, aligned, maintaining perpendicularity and parallelism, making sure everything is perfectly in balance, and all those things. Making sure we replace fasteners, not using the same worn-out fasteners, making sure we use proper tensile strength of fasteners, etc. So really, that's maintaining the physical integrity and alignment of that equipment. We also have inventory control. We'll talk about that in a little bit. Vendor control, I'll mention that later as well. Key performance indicators. So a lot of these things we're going to be discussing are strategies to actually prevent. And so you can see things all the way down to the bottom: planning and scheduling, computerized maintenance management, etc. So we're going to talk about some of these. So all the ones on the left are what we call mitigation strategies, the things we do to prevent. The ones on the right are all detection strategies, the things we do to find. So you got to have both. Unfortunately, you can't just have detection. You really need to prevent, but you can't prevent everything. Some things are going to slip through. Now, taking this, and I kind of broke it up into 5 major phases. The first phase is operator focus or operator engagement. How do we get the operator, a key part of that whole picture of the interface of human and equipment interface? How do we get that person more engaged in the practices of taking care of their equipment? So phase 1, you got to get that operator engaged. Number 2, phase 2 is preventive maintenance program. Put in a good, strong, robust PM program and a good information management program. Now, we call information management, when it supports the equipment, we call that a CMMS, which stands for Computerized Maintenance Management System. You better have the right one, because they're not all of equal value. I've helped companies install some of the most sophisticated ones and some very simple ones, and they all don't perform the same. And an expensive one doesn't give you less headaches. So you have to have a good information management system. You got to have a good PM program, but you also have to do planning and scheduling at this point to really get the most productivity out of your workforce. Now, phase 3 is lubrication. Now, that one actually crosses multiple areas, including operator care. It covers preventive maintenance. It covers predictive maintenance. So a lot of things, because it's a broad spectrum. That's the lifeblood of mechanical equipment. We want to make sure it's done right. Otherwise, we don't see the damage that is when it's done incorrectly. Unless you're doing oil analysis on a frequent basis and responding to those things, everything may look fine. Hey, I see some grease, looks like lube levels are topped off well, etc. Now, phase 4 are stores, and that's making sure you get the right part at the right time, the right condition. Now, there's a whole economic set of principles to be able to make a decision on that, and I'll share with you that a little bit later. The phase 5 is root cause failure analysis. How do I identify the root cause, and how do I prevent this from reoccurring? Very important. How do I keep this from happening again? So these are the 5 phases. So what I like to do is introduce you to the first phase, which is operator focus. So operator focus is getting the operators engaged with equipment. What you see here is a process guide for one of our clients, and it basically outlines the major components of an operator care program. Generally, what we're talking about is developing standards. As you see on the right, it's an actual operator care standard. And what it does is it serves as a graphical pictorial to help that operator know what they're supposed to do, where they're supposed to do it, the frequency, how well, etc. This is called an operator standard. And so you can have them for lubrication tasks, inspection tasks, cleaning tasks, etc. These things are usually laminated. They're kept on a waterproof box on the equipment. And we make sure that they're using these things so they don't rely on recall. Now, the main thing is that when you set up the equipment conditions by getting the equipment in a decent shape, you set standards, you identify the changes or any problems, you restore it back to standard, and you continue this process over and over again. The whole thing is that the standards set the expectations of how we keep this equipment. You can see that example of that D3 there, but it can be any piece of equipment. So we train them. It usually takes about 2 to 3 hours to train an operator to perform to these standards. You share with them the expectations, and then, of course, you give them a little time to start practicing this stuff, and you got to go audit it. So what you see here is an example of an actual operator care audit for a pickup truck. So the auditor would go out there. As I said, it takes about 3 hours to train an auditor. I just trained some last week in Portland, Oregon. But what you do is you train them to go out there and examine this equipment. Are we maintaining this equipment to this standard? And if not, maybe this person needs some additional coaching. Maybe they need additional training. But we want to be able to make sure they understand the expectations for how this equipment is to be maintained. So that's the part of that. You have to inspect what you expect. So those are the key things. The operator care piece is getting the operator engaged, elevating their skills and knowledge so they understand the importance of the process, how it works, etc. Now, the next piece or phase is the PM and information management focus. Now, one of the things we have to do here is, first of all, realize all equipment is not of equal value. You got to classify equipment from most critical to least critical. Here's an actual spreadsheet that was used for one of our clients that helped them to determine what was the most critical of the equipment. And you can see here when it goes through, there's about 3 characteristics they look at, and then from that it gets classified as either an A, B, C, or D. A is what we call mission critical. Usually there's no backups. When it goes down, it has a major financial impact to the operation, or it can create a serious risk to life or limb or environment. It's always going to be a very critical piece of equipment. B's are similar equipment, but I may have a backup. I may have a workaround. So it may not have the same level of impact should it go down. Then we go down to the C list and the D list. And D list might include things like lawnmowers, etc. Low impact if they go down, just not going to see a lot of pain. So very important that your equipment gets classified, because that's how we handle it. Most critical gets your most extensive preventive maintenance programs, and gets the most extensive auditing, gets the most extensive examination, etc. Another thing you have to have is key performance indicators, KPIs. The KPIs are measuring, it's taking measures and looking at it. This is an actual measure from one of our clients. They were measuring their breakdown or emergency rate over years. And you can see it shows all the way from 08 to 2017, when they were able to get it down to where we want it to be, which is 1 or 2%. And so, but it's a struggle to get it down to that rate. You got to remove a lot of the contributors that cause these breakdowns to occur. And unfortunately, there are many of them. So this key performance indicators is measuring. It's very difficult to manage what you can't measure. And what gets measured gets improved. And so this is an example, and we call these KPIs or key performance indicators. Another thing is having a good, robust CMMS, computerized maintenance management system. It's very difficult to do this stuff reliably with just paperwork and trying to remember things. So you want a good CMMS will trigger PMs, be able to take in work requests, be able to record your predictive maintenance program, and it generates work orders. You then feed it history, and the most important thing is getting the reports out of it. Because if you can't get good information, a reliable report, it's not a very good CMMS. I've seen a lot of CMMSs. You feed it like a beast, but it gives you nothing in return. And you need to be able to look at histories, trends, and patterns to be able to tackle those things later. So a CMMS becomes a very, very important part of this. Now, part of this is to understand the whole nature of what we're trying to do with that CMMS. If you look toward the bottom there, you can see operators have their operator assignment, their equipment that they're assigned to, and we want to engage them in operator care, doing their daily clear tasks. We also want that they'll have some surveillance activities they do on the equipment or multiple pieces of equipment if they're responsible for that. And also you try to rely on some kind of alarm management that measures using sensors and other things to give you early indications you got a problem. We also apply that with a maintenance program. So we take our equipment strategies, our maintenance plan, our materials management plan, and all those things are consisting of the practices or tactics of preventive maintenance, predictive maintenance, corrective maintenance, proactive maintenance, planning, scheduling, inventory control. So what we do is we look at the records that come from that, the information that comes from that, the history, and we feed that into our CMMS, and it tells us stories. And it will tell us and identify failure data. And we'll start seeing common patterns and trends. From that, we can then do something called RCFA, root cause failure analysis, and figure out what causes this to occur and what can I do to prevent a reoccurrence. So once we do the RCFAs, they usually result in some kind of corrective action. We can make modifications, make improvements, etc. But they also will generate measures of those actions. So did we hit the mark? Did we make change? And those KPIs go to leadership to let us know, hey, we're making improvements here. We're reducing this issue. We're improving our costs, improving our uptime. So that's why having a good computerized maintenance management system is essential. It's essential for any organization to have a good program that can be able to collect this information and give you the necessary reports and allow you to be able to see those trends and patterns. Now, part of this is also to make sure that we're doing planning and scheduling. So you see this little chart here, it's called the maintenance activity model. What we do over here on step one is we have a way to properly identify work. We usually call that work notifications or work requests, and prioritizing the work based on the criticality of that equipment. Is it A, B, C, or D? Because that'll tell you the sense of urgency I'm applying to this job. Now, we send that notification in, and then for non-emergency work, we plan it, which means we prep it. We order the materials, we prepare a job plan, which is job procedure, we identify any specialty tools, all of that. Once we develop the bill of materials, we then forward that on to parts room. They pull those parts, and everything is ready. Now, once everything is ready, we can schedule it. So we schedule it to identify the resource and the timing for that job. So if you think of planning as the what and the how, the scheduling is the when and the who. Now, the next thing is we basically go execute the job. And that's making sure people have the proper skills, they know how to troubleshoot, they know, understand the systems that they're working in. And then 5 and 6 is review and improve. And review is analyzing and looking at things and being able to figure out what went well, what didn't go well, and then identifying what we call repeatables and changeables. Repeatables are things you want to continue doing, and changeables are those things that weren't quite hitting the mark, and therefore we want to go ahead and make some changes to it. So this is a 6-step process, and this is very important because a lot of companies only do number 1 and then number 4. Some do number 1, number 3, and number 4, but not a lot of them do plan a really good thorough job of planning, and a lot of them don't do a very good job of looking back and analyzing. So we also have a PM procedure with our specifications, and here's an example of a PM spec on the left. It's a 500 hour for a 1055 paver. And here's what you'll often find instead would look something like this. We call this check this and check that. So it doesn't have any specifications. The one on the right doesn't have any specifications. It's just telling somebody to check this, check that, check. So you're leaving it up to the interpretation of the person doing this inspection. You don't want to do that. You want to put the specifications in so they have a reference and they know what the standard is supposed to be and not trying to remember what all the standards are. So those are some of the key essentials to the PM, information management, and planning phase of phase 2. Now, phase 3 is lubrication. As we said, that covers all the way from the operator piece of proper lubricating and checking lube levels and greasing to a good PM program of all the tasks that occurred in for the maintenance and, of course, predictive maintenance as well. Now, here's some of the key essentials on lubrication. Making sure it's properly stored in a controlled environment. Unfortunately, a lot of people still store their lube bulk containers outside. Well, the variation in temperature will cause condensation to build. We call that the dew point. And when it reaches the dew point, that takes that moisture that's in the air and will now cause condensation to occur. And that will occur in there when you've got greater than a 15-degree temperature differential between the inside and outside. So one of the ways to do that is try to have a little bit more environmental control. So you can see these are called polypros, polypropylene containers. We can actually see through them, see the levels, color code them to match the lubricant, the actual lubricant source on the equipment. Another thing is using color coding as much as possible, mistake-proof things, so you know what lubricant goes where. Everything is not one size lubricant. Everything is not one type of grease. Down at the bottom, you'll see little labels and grease fitting caps. And these can be used to color code the frequency of the lubrication, daily, weekly, monthly, or it can identify the type of grease. Another key thing is grease guns. If you got more than one grease, which you usually need to have more than one grease, you can't use an EP additive on motors because it'll attack the windings in the motor. So you don't use a grease with an EP in a motor, so you don't want to mix that up with the ones that you use in bearings. So you want to color code your grease guns, and you want to analyze this thing for proper service and making sure that we know the proper amount to apply. It's not grease till it, it's not one grease is good, two is better, and 50 is outstanding. It's that we need to understand the proper amount of grease. And generally, grease is not numbers of shots. It's supposed to be in weight. And we can actually calibrate grease guns so that it gives you weights. Now, standards are, as I showed you earlier, standards are identified. They're laminated. They're posted at the equipment so the person doesn't have to try to remember all those lube points. Another thing is making sure that we wipe the grease guns. We take care of them to minimize contamination. We wipe the fittings before we dispense, but we put that coupling head down on there. We don't want to shoot that contaminated grease blob into that bearing. So what we do is we wipe the fitting afterwards to just ensure that it's in a good condition. Now, and certainly before you apply it. Some people can choose to leave a blob of grease on there. That's fine as long as you have a way of removing that grease before you actually apply the grease. And one thing you just got to remember is that bearing cavities are designed to operate with a grease charge of less than 50%. So if we keep packing the grease in there, we're actually displacing that space for cooling, and you can overheat the bearings. And that's why 80% of all bearings never live to their life expectancy. Another thing is making sure we have lube charts, that you train your operators and mechanics in proper lube techniques. They don't know. They didn't learn that in high school or whatever. You got to train them properly, how to use a grease gun. There's a big variation in the output on those grease guns and stuff. Lube containers, color code them to match the type of lubes, which would then match color points on the equipment, and keep them sealed. The top should be sealed so that you don't get contamination. Down on the bottom shows a lube label that you would identify what type of lubrication goes into this piece of equipment. Now, one of the things is that we don't realize is the level of contamination that's in our systems, whether it's hydraulic, lubricants, or whatever. So just got to give you a perspective. Most gearbox damage is less than 10 micron. Considerable gearbox damage is in the 2 to 5 micron range. Now, if you look at it, 100 microns is about the size of a grain of salt. 40 microns, which is the smallest that a human eye can see, is 40 microns. Now, you can see it starts getting down, if you couldn't even see it, a 2 to 10 micron size particle. So that's why we don't rely on visualization of looking at the oil. Instead, we rely on things like oil analysis. It's a predictive tool that helps us to be able to identify the presence of contaminants in the oil so that we can respond and take corrective action. Now, because if we don't, then obviously that's going to degrade the components and degrade the performance of that equipment. Now, one thing a lot of people don't realize is that when you're pulling an oil sample, you're really supposed to generally pull two. One's a half sample, a partial sample. The other is your final sample. The partial sample is really to clean the orifice so that you're not getting any particulate, dirt, or silica into your oil sample and give you a false indicator or a false reading. Now, why do we do it? I kind of already stated, we're trying to prevent premature failures. We're trying to extend the life of the equipment, increase uptime, and improve equipment availability. Now, look at some of the tests. There are a wide range of tests you can do. Here's some of the more common ones. Spectral examination. The oil sample is run through a spectrometer. It analyzes oil and calculates the levels of various metals and additives. Also, it gives you a gauge on how much the engine is wearing, so you can kind of determine the level of wear that's occurring in that engine. We can another test that is common would be the insolubles test. So the insolubles test measures the amount of abrasive solids that are present in the oil. Okay, and because it really tells you how well are you collecting this through your oil filters. Think of your kidney working on trying to clean the contents that come in through your body. We have a lot of contents, liquid contents come into our body. Your oil filter works very similar to try to keep those impurities out. Now, viscosity is the thickness of the oil, and many things can affect that, and that's what we want to find out. Is there something that's affecting it? Like fuel, the presence of fuel, water, or moisture, coolant, other types of things. Is the heat breaking it down? So that's why we do a viscosity test to see is there anything that's affecting the thickness of this oil. Now, another test is flash point test, and basically it measures the temperature at which vapors from it ignite. And for any specific grade, there is a temperature that the oil should flash at. And if it flashes pretty much around there, we're in a good state. However, if it flashes off lower than it should, it probably could indicate that you have fuel in your oil. I mean, you have a leak somewhere. Now, part of this is understanding that oil analysis really should be gathered before the scheduled PM, so that you can take corrective actions while you're actually doing the PM. It'd be like going to get an annual physical. You want to be able to make sure you do your blood test well in advance so that you can discuss the characteristics of it when you're there. Another thing is what we recommend is you have a certified tribologist. And Dan will be more than glad to answer questions about this. There are various societies out there that issue certifications for about $500. You could take the test. You'd have to do some studying. But there are different certification levels, and Dan will be more than glad to explain those levels later on. So phase 4, making sure you have the right parts at the right time in the right condition. And I believe that information, what we call MRO, maintenance, repair, and operational supplies, which is the inventory of maintaining parts, etc., in the storeroom. You're balancing a lot of different things. You're balancing the cost to carry it. That's your holding cost or carrying cost. That's the cost of the facilities, the personnel, utilities, taxes, pilferage, losses, everything to run that storeroom. Then there's there's an ordering cost. That's the cost to generate a purchase order. So what we're doing is trying to make choices between what do we keep on hand versus what we actually direct buy. And there is some formulas. Here's an example of an EOQ that shows there's a sweet point for the EOQ, economic order quantity, of how many I'm going to order at my reorder point. Another thing is vendor management. It shows you an example of a form used. This is used by Gorman to rate their vendors on quality, delivery, customer satisfaction, pricing, etc. You want to be able to rate them and help them identify and address any particular issues. The last of these deals with root cause failure analysis, and that deals with identifying the problem and figuring out how to prevent a reoccurrence. So you got to get to the root cause of it. Here's an example of a checklist used by some of our clients to help to identify what needs to happen to go do an RCFA investigation. And usually we recommend more than one person to do these things because people have their own pet peeves and preferences and biases. So in summary, we talked about the operator focus, engaging the operator. We talked about building a good, solid preventive maintenance program, having the right kind of robust computerized maintenance management system, doing some planning and scheduling. We talk about the importance of lubrication, of, maintaining storage and color coding, maintaining a good oil analysis program to give you early indications of problems. We talked about storeroom and managing the stores as a matter of economics. And then finally, the root cause failure analysis on finding out what caused this to occur and how do I prevent a reoccurrence. So that sums up the process here. And I'm going to turn it over to Haley now to see if there are any questions. Haley?
Hi, yes. And so we do have a couple questions, but before I read those, I would like to remind everyone who's listening in right now that you can, on the question tab of the grab tab on the left of your screen, you can submit questions while I'm reading off the questions I have already anytime during this time. So just make sure you guys are doing that if you have any. So the first question we have is, my new equipment hauling tractors are factory filled with 10W30, and all of my other equipment uses 15W40. Can I consolidate to one?
Dan, I'll let you answer that.
Well, thank you, Preston, and thank you for that question.
Oh, by the way, that's Dan the man there.
Thank you, Preston. I was amazed you got all that information in there. That's quite good and quite comprehensive. So thank you for that presentation. And that's a common question, Haley, that we get out in the field quite regularly, because a lot of the over-the-road truckers and trucking companies and the OEMs, they have a certain mileage or carbon footprint to meet by government standards. And so they're going to the 10W30, a little lighter viscosity oil. And what we call viscosity of the oil is actually the oil's internal resistance to flow. So if you can lower that viscosity, lower that internal resistance, you're going to lower some of the resistance in the engine. So you're going to get better fuel economy. It's not a great deal. You're talking, 1 or 2% overall for fuel economy. And that's important to those folks that are running over the highway and trying to save on that fuel economy, or those OEMs that are meeting a certain, what we used to call CAFE requirement for the automobile. You can most certainly go to a 15W40 for consolidating in your personal fleet when you have that off-road equipment that may not be running down the highway. You're not as worried about that fuel economy, but you want to protect your engine. It's better to go to a 15W40 in those applications versus taking everything down to a 10W30. Unless some of the more modern equipment, they're beginning, even in the off-highway equipment and the heavy-duty dozers and stuff, they're beginning to look at 10W30 in the future. But that brings me to another question or comment. And I'm sure, Preston, you've heard about API, American Petroleum Institute, and some of the ratings on the engine oils. You've heard CK4 and FA4, and we used to have CJ4, and that sounds like a bunch of alphabet soup, I imagine. But the old compressed ignition, like the diesel engines, it was the API CA, CB, CC, on up to it's now CK4. Every one of those subsequential categories could replace the previous one. So CK4, that is good for any engine that required a CJ4 or a CD4 or something of that nature. This FA4 is for fuel economy, and it's the first of its category, and it deals with a little bit lighter viscosity in that load zone in the engine. And so not all pieces of equipment are designed to handle that. So you want to stay with the API CK or CJ4, and I would go with the CK4, because each one of these oils, as we improve them, or we go up a category, we improve them somewhere along the way. And CK4 improved oxidation and wear protection versus the CJ4. So that's a good product to go to, and I would go with the 15W40. Thank you for the question.
Absolutely, and thank you for the answer. Another question we have is, do I really need to keep my oil as clean as the OEM says? And if so, how do I do that?
Dan?
You're going to let me handle that one too? Absolutely.
I told you
Yeah.
I'm going to get all the food questions.
Well, I liked your one graph there showing the 100 micron and the 40 micron, and the naked eye could see down about 40 microns. Most hair follicles are, 70 to 100 microns in diameter. I actually do have a full head of hair. It's just that most of it's about 20 microns. You just can't see it, and you can't feel it. You can't feel it either. So I've had a lot of people say they'll grab a little bit of oil and feel it. And just like you said, it's those small particles, those 2 microns and 4 micron particles that cause the most damage. If you think about your valves and your bearings, the clearance between those moving components there, they're a micron or 2 microns or 5 microns in size. And if you have something that's 10 microns or something you can feel at like a grain of salt, 100 microns, it's not even going to go through those moving components, not going to cause you damage. So with today's equipment being higher pressure, heavier loads, and tighter tolerances in them, it is very critical, becoming even more critical that you keep the oil clean. And there are several ways you can do that, and I think you touched on a few of them, Preston. One of them with greasing. I like to recommend people, once they grease that grease circuit or bearing through a grease circuit, leave a bit of that grease on the outside. That kind of acts as a sealant, and you wipe it off before you put the grease gun back on there the next time. That way you got a nice clean surface and you're not shoving any dirt in there. Keeping the bungs in the drums. If you're storing it in drums, put a desiccant and particulate filter on your storage units, whether they are drums or those polypropylene tanks you talked about. Plumb them together on the vent portion, so you can run them to a desiccant breather that removes moisture. And I also have a particulate filter that keeps dirt out of it, keeps that oil as clean as possible. The other thing is funnels. I like to throw away all those funnels out there, and if you can, go to a paper funnel. It's a one-time use. They're folded up. You open them up, quickly pour the oil in there. You're not adding a lot of dirt because you got a little moisture in your funnel. Let it sitting around, it's going to collect some dirt. So try to avoid using them as much as possible, and make sure you use those clean containers when you're transferring oil from one to another.
Good point on the funnel.
Sorry, Preston, go ahead.
No, I said that was a really good point on the funnels, because they often lay around and they're sticky and they collect all the dust from the environment.
Yes, and keep those lids closed.
Excellent. And then you both seem just beyond knowledgeable about this subject matter. Is there any other common questions that you guys hear on this topic that you could share with us?
Well, the one I'd like to, and Dan could probably elaborate on this. I mentioned earlier about having someone in your organization that knows the field of lubrication. It's very important because it's so much to understand, but there's so many mistakes you can make. And we just giving you a few. There are far more problems with that. So as much like a hematologist, they learn the science of blood and how to take proper samples and stuff. You have a handling procedure, a storage procedure, and all those things, and it's very important. So a tribologist is something you don't need a degree. You study the material, you take the test, and you receive the certification. And I encourage our clients to move to that, at least have somebody, one of the mechanics or technicians, to that, because the preservation of the machine's vital blood is important in contamination control.
Very true. That tribology, that STLE, Society of Tribology and Lubrication Engineers, or if you go to stle.org, and you can look online there, and there's a body of knowledge you can study on whether it's oil monitoring analysts. Study that. You can go ahead and take the exam afterwards, but it's not just a matter of the lab pulling samples and giving you results. You really have to interpret it, because as an example, if you had a coolant leak in your engine oil, it will not show up as coolant because the glycol will vaporize off when it's an operating temperature. The water will definitely boil off out of that engine oil. But what you're looking for is things left behind like sodium or potassium that are some of the additives in the coolant, and that will quickly tell you that you have a coolant leak, and that's very necessary to get that corrected.
Awesome, guys. Thank you for that. And thank you for everyone for attending today's webinar. Before I close this out, I'd like to turn it over to Dan real quick for a couple words, and then I'll close this out.
Well, thank you again, Preston. Very, very insightful presentation. A lot of good thought-provoking ideas in there. Certainly something to keep in mind as we set up our maintenance programs. And we certainly want to thank you, our listeners, for attending today's webinar. And we hope that you have gained some innovative information on running your business more effectively. And if you have any questions for the speakers that we were unable to address during our call, please feel free to send them to me or to Preston. And you can do so, or you can do so by replying to the email you received from GoToWebinar with today's login information.
So thank you, Dan. And if you would like to view the webinar again or send it to someone else in your company, you can download it at www.equipmentworld.com/webinars. And you will also get an email with a recorded presentation tomorrow. And thank you again, everyone, for attending, and you guys have a great day.
Thank you.